equal sign and like tell me what to do. It's crazy. I don't know. She's kind of odd. That's what she likes to do. All right. Okay, next. Move to this. Let's do this one. This one's the easiest one. If I want to isolate x, we know the answer is 5 there, but how would we do it using these steps? Clear all parentheses. There are no parentheses. Okay, collect like terms. Put any numbers and any x's together on each side. So over here, can you put x and 4 together? No, they're not like terms. Over here, there's just 9. Okay, so can't do anything there. Step 3, isolate the x. That means get your x by itself. So how are you going to get that x on the left side by itself? You've got to get the 4 out of here, right? And to get the 4 out of there, you have to subtract it because it's being added. So whatever you do one side, do the other. So I think a lot of you have seen this way. This is called the vertical method. Where you just kind of do that little thing and then kill off your 4s here. And that gives you x. That's the only thing left over here, and then equals this side, which is that. And that's it. You've isolated x, right? So x was 5, and that's what we knew from the beginning. Okay, let's try this one. What do we do here? Clear parentheses. There are no parentheses. Collect like terms. Can you put those two together? No. Just 9 by itself. Can't do that. Okay? Now I need to isolate x. So how are you going to isolate x? You're going to add 4. So I'm going to add 4. What about the 3 and the x? What's the operation between there? What's that operation? Multiplication. So if you have anything attached to the x, right, it's kind of opposite of what you would think. You're actually going to leave that alone until it is alone by itself. So we have to isolate this term first. We want to get that term by itself. So we will add 4 to both sides. Excuse me. Add 4. Add 4. Boom, boom. And then over here they cancel. You just have the 3x here. And then equals, and then what's that? 13? Okay, now we have to deal with the 3. Divide. Now, the reason we're dividing is because we're trying to do the opposite of what's there. See, like with this, we had plus 4, we subtracted 4. Here we had minus 4, we add 4. Here if we have times 3, we're going to divide by 3. So we're undoing it. Divide by 3, divide by 3. These 3's cancel. It's actually 3 over 3. 3 divided by 3, which is 1. So we get x here, and then equals this right here. We'll just leave it, 13/3. And we'll be done. So the answer is 13/3. You leave it as an improper fraction. You don't need to do anything else. Oh, wrong class. Let's just get right into it. Let's see where you are with this. Yes?
On the rules,
Yes.
where can you put it in replace the opposite?
Oh, do the opposite in the rules? That's kind of like that step. So I'm not technically writing it down like add or subtract to both sides. Yeah, it's within this step when you're isolating that you're either going to be adding or subtracting things from both sides, or multiplying or dividing things on both sides. And it's all going to be whatever it takes to get x by itself. So let's work number 18. Hayden. Where's Hayden? Hayden? Hayden's not here. I'll pass the sign-in sheet around, by the way. There we go. Hayden, no Hayden. Diego, you're up again. Oh, we're doing number 18, Diego. And I wanted to know, if you go through here, it says clear parentheses first. Then, do you see anything that you can do to clear parentheses? Excellent. Okay, so here, right here, you have parentheses, 3x plus 5. In here, you cannot do anything, right? 3x plus 5, nothing you can do. However, to get rid of the parentheses, you can take this 2 that's being multiplied and multiply through. We call that distributing the 2 through. Now, while we're doing this, on the left-hand side of the problem, Hayden, does, what about this? It's all right. I distribute the 1? What 1? Yes, good. So this is a hidden 1. It's actually a 1 right there, right? And you can imagine doing the same thing we did with the 2 with the 1, like this. 1 through here, 1 through there. So what would the next line read? Go ahead. 10x plus 4 minus x. Good.
7x plus 6x plus 10.
Perfect. There we go. Okay. So we have cleared the parentheses. Callie?
Yes.
Yes. You got that down?
Yes.
Okay, so now next thing would be to try and collect any like terms together. So by like terms, we mean like put numbers with numbers, put x's with x's. So anything to collect on the left-hand side, Callie.
You could, the x and the 10x.
10x and the x, I put those together, what would it become?
9x.
9x? So you're just basically looking at that as a 1x, right? 10 of those, take away 1, you've got 9x's here. And then you still have plus 4, you couldn't do anything with the 4, right?
Right.
Okay, and then Callie, what about the right side?
The 7x and the 6x.
Okay, add those together. 13x plus 10. Good, Callie. All right. Uriel?
Yep.
Yep, how you doing? So we've collected like terms, we cleared the parentheses, we're trying to get x by itself. Any ideas on how you would get x by itself here?
One of the x's to one side, so minus 13x over to 9x.
Okay, so you said you want to get the x's to one side, right? But right now there's x's on both sides. So which side do you move the x's to? Does it matter? Or
I think that side.
it doesn't matter, actually. Now, most people get them on the left. But it actually doesn't matter which side the x goes on. Because remember, you said you could switch them around, right? So, but you said you're going to subtract 13x from both sides, right? Is this a legal move, everyone? Could you subtract that from both sides? Right? I mean, it's the same thing on both sides, right? So that is legal? Let's just follow through with it and see what happens. Since you suggested it, what would the left-hand side become?
Minus 4x.
Minus 4x. Then what?
Plus 4.
Plus 4. And then equals, right? And then what?
Equals 10.
I didn't hear you.
Equals 10.
10. Okay, sorry. I thought you said 7. Okay. Do y'all agree with that? That's right. I mean, that is, we are on the right path. Now, someone else may have done something else, but we can go back and revisit that in a second. Okay, what would be the next step, Melissa? Where's Melissa? Okay. Still trying to isolate x. So far, we've got x over here on the left side, but we've got some other stuff there, so what would you want to do here? Subtract what? 4. You look skeptical on yourself there. You're subtracting 4 to get rid of it, right? Because if you get rid of that, you'll just have the x there. So subtract 4 here, subtract 4 here, boom, boom. And then left side would now become negative 4x. And then right side would become 6. Okay, Emily? Now divide, because you have multiplication here. Divide by what? Negative 4. Okay, divide by negative 4. So when I do that, I'm just going to write this, divide by negative 4, this, divide by negative 4. This and this cancel, become a 1. So all you have is x over there, equals negative 1 what? 1. So if you go to a decimal, yes. I'm going to leave it as a fraction, though. Could I go negative 3 over 2? What did I do here? I reduced the fraction. 2 goes into both of these, right? 2 goes into both of those? I have a question. This is going to come up later. Is this also correct? When you have a fraction and you have a negative on the bottom and a positive on the top, is it okay for you to take the negative and slide it to the top? Yes or no? Just go with your gut. What do you think? Yes? Yes, you may. All right? Think of it this way. What's 1 divided by negative 1? What's 1 divided by negative 1? That's negative 1, right? What is negative 1 divided by positive 1? Still negative 1, right? Same thing here. 3 divided by negative 2 is going to be a negative number, right? Negative 3 divided by 2 is still a negative number. And in fact, you can put your negative out in front of the fraction, and that would all three of these are correct, and they're the same thing. I'm just showing you that because as we move through this class, I might get a negative on the top or the bottom, and you might see me like move it somewhere. And it's because I can. It's legal. It's allowed. So the answer to number 18 is negative 3/2. All right. We have 5 minutes. It's Monday. We'll call it a day. Yeah? We'll come back. Do what you can. Do what you can on the homework for solving equations. I'm sure you're going to get hung up. Well, maybe not. It depends on you. But do what you can, and then we will come back and do more solving linear equations, hopefully based on whatever questions you have on homework. And then we'll continue. Proceed on. Was there anyone else that did not give me a stick with your name on it? Yes? Yeah, can I show that real quick? Because I kind of said I was going to. You're free to go. I'm just going to show something right here. So at this point right here, remember our answer is negative 3/2, right? So how do you decide to subtract the 9x? That's what you're referring to, right? And you'd maybe want to do that because that stays positive, right? So what does the left side become? Equals 4x plus 10. Okay, now you have to get the x by itself, right? What's that? Right, what? You don't have one of those yet? Yeah, go ahead and just take a marker and put that in. Okay, minus 10, both sides. And then negative 6 equals 4x. Divide by 4. Reduce that fraction, you get negative 3/2. See, and that's the same thing. So, I mean, there's good news with that because either way, you're going to get the same answer, right? Okay. Thank you, sir. Yeah, let me turn off the camera.